Hello, students. Mr. Hausneck back again. This will be the third screencast in our series of three. First two being primarily review. The third will be review for some, enrichment for others. It all depends on if you have covered free body diagrams in your class up to this point or not. So let's get to it and let's take a look at what free body diagrams are. The term free body comes from removing an object from its environment so you can only look at the forces acting on that single object. You can see here there's four different forces acting on our object. Objects are typically represented with a box or maybe a circle. And you happen to notice that there's balanced forces here. Vertically, they're balanced. Horizontally, they're balanced. So that means there will be no motion in terms of this object. When we go to our first example here, you can see here a balanced forces vertically. So there's going to be no movement of this object vertically up or down, but there is going to be some movement to the right because it's indicated by this larger arrow. And when we see that, we know that there has to be more force acting in this direction than opposing. So we call that combination of all forces the net force. And when you take 10 newtons from 15 newtons, you get a net gain of 5 newtons to the right. So this will actually move not up or down, it'll actually move to the right. The second example here shows you very similar pattern to the last one. The only thing here, you don't have any balanced forces here. You have unbalanced forces vertically, in this case 5 Newton force up, and you have a 7 Newton net force to the right. So the actual motion of this isn't going to be up or down or left or right. It's actually going to be doing both. So it's going to be accelerating upward in more of a curved motion. Okay. And number 3 here, if we focus on this object, the crate, we see that there's a balanced force vertically, and there's an applied force of 32 newtons to the right. What this problem is asking, if you read it, is what is the size of this force here? Now, we are told that the net force is 24 newtons. So that means there's an overall force of 24 newtons in this direction. So if our applied force is 32 newtons, to figure out what this force is, all we have to really do is take 24 newtons, which is our net force, subtract it from our force that's applied to the right, and that's going to give you 8 newtons. So that means there is a force of 8 newtons that is opposing the motion of the applied force. So overall, we're going to get a net gain of 24 newtons to the right, and that's why this crate will move to the right rather than moving to the left, because we have overcome the force of friction by quite a bit, basically by 3 times. Okay, sometimes you really don't get sizes or magnitudes in your free body diagrams. We're just trying to identify the forces that are acting on an object. And you consider this coffee cup here. We have the force of friction that's opposing its motion, moving downward. Of course, gravity is forcing it downward. And then you have the normal force that's acting on the bottom of this coffee cup from the ramp. So this ramp is actually pushing up on the bottom of this mug. So 3 different forces acting on this mug. Same thing can be said of the hockey puck here. If you look at this diagram, 4 different forces acting on this hockey puck. So time to challenge you a little bit here. I kind of did it for you, and I'm sure your teachers will challenge you with maybe some online different examples. But if you look at this problem, we're looking at a chair, and it's accelerating with rightward acceleration. So basically, it's moving to the right, and we want to consider both the force of friction and also neglect air resistance. But we know that there is other forces acting on this chair, so we want to diagram those forces. So we know that gravity is pushing down or pulling down on the chair. So that is represented with this arrow. The normal force pushing from the ground up on the bottom of the chair is here. Our applied force to the right, and then the force that opposes our applied force is our frictional force. Now, the reason that this arrow is bigger, if you remember, because there's more force in this direction than in this direction. We have overcome friction, and therefore it's going to be accelerating to the right. So that's just a real quick, brief overview of free body diagrams. I'm sure your teachers will introduce some different links that you can explore. Thanks for tuning in, and we'll see you on next week's screencast.